What's happening, y'all? In this video, we're going to see how to use MATLAB's IsA function. This is part of our larger discussion of how logical data can be used in MATLAB. Remember, we said that the logical data class really shows up in four ways when we're coding. The first was using logical operations. We saw many examples of how to do that using AND, OR, NOT, XOR, etc. We've also seen a number of examples of how to use logical data to capture relational operations or to test relations between two numeric variables. We're now moving on to the third purpose here, which is to test the state of MATLAB variables. In order to understand what we mean by testing the state of a MATLAB variable, let's go back into the documentation. We'll go down into MATLAB, we'll go to language fundamentals, and then we'll go to data types. Remember, in this discussion, we had this fundamental MATLAB classes, and MATLAB was claiming that there are 16 array-based classes, which we see here, and then one scalar-based class, which is called the function handle. This documentation is going to be central to our discussion for the IsA function. In order to understand that, let's go over to the little plus button. That's going to get us to a new documentation query. Let's go ahead and type IsA. And then notice that this comes up with a function, determine if the input has a specified data type. Let's go down to that specific value. What I'm going to do here is actually go over to the split screen. So up on the top, here's that little split screen, and that allows me to compare two different types of documentation. The claim that I'm going to make here is that the IsA function, which is designed to determine if the input has a specified data type, notice the syntax of that function is TF on the left-hand side. Could you guess what TF stands for? Ding, 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 ding. You got it. That stands for a logical scalar whose value is either logical 1 or true or logical 0, in other words, false. So on the left-hand side of this thing is going to be a logical scalar. On the right-hand side, we're going to use the IsA function. And then we notice that the IsA function has two inputs. The first input is going to be some type of data. And then the second input is going to be known as data type. If we look at the description, we say that TF equals IsA of A comma data type. This returns 1 if A has the data type specified by data type. Otherwise, it returns a 0. Notice also that the input argument can be any type of data. We can scroll down to some examples where MATLAB is going to run us through how to use that function. So in this case, MATLAB is storing the value 3.1416, and then it wants to know, is A stored as a double? In this case, MATLAB is reporting that this result will be true. Let's go ahead and test that for ourselves in MATLAB's command window. We'll go ahead and copy and paste. The claim is this value of A is going to be stored as a double. That's exactly what we see if we go over to the workspace. Notice that A is stored using the double class, whereas the variable TF, the output of the IsA function, is stored as a 1-by-1 logical scalar. In other words, this IsA function allows me to tell what class am I using to store my data, right? This is what we see in the workspace, and report the results as a logical scalar. MATLAB runs through some other documentation where we're going to use the int32 function to store this as a 32-bit signed integer, and then a test is the value of A stored using the int32 data class. If we continue to scroll down, there's a lot of information about the data type parameter in this function. Specifically, we can do one of 16, actually it looks like 17 different tests. Is it a single, a double, an int8, an int16, a uint32, a string, a character, a function handle? We also see some information about different categories of data. We're going to cover that in detail. Specifically, all of this relates to the fundamental data classes and a lot of the content in this documentation. The point of this discussion is to give a brief introduction to different classes of data. With that, I've created a table that kind of summarizes some key attributes of data that we're going to go more into as this class advances. We'll start with logical data. We've been speaking a lot about that. Remember, each piece of logical data can be stored as an array, and then the individual entries are stored as logical scalars, or 1-by-1 logical data, whose entries can take one of two values, either logical 1, which means the corresponding test is true, or logical 0, which means the corresponding test is false. So that data class is literally the logical data class. The next data class in our list are called strings. String arrays are stored using the double quotation mark, so both quotation marks at the same time. And we use those in MATLAB when we're processing a lot of text, so full sentences or paragraphs or information on websites, etc. On the other hand, we say that the character arrays or character data is stored using single quotation marks, and that's really looking at individual characters as individual entries in an array. Again, Strings use double quotation marks, while characters use single quotation marks. We then move down to 10 different classes of numeric data. These are really partitioned into 2 different categories with a minor subcategory. The first set is what we call unsigned integers, or just integers. That's the uint8, uint16, uint32, and uint64. These are unsigned integers. In other words, uint means unsigned integers. In mathematical terms, that means these are non-negative integers starting at 0 and then moving up by whole numbers. So 0, 1, 2, 3, etc., etc. The numbers at the end of each data class represent the number of bits that we use to store that integer. So uint8 stores unsized integers using 8 bits. uint16 stores unsigned integers using 16 bits. uint32 uses 32 bits to store unsigned integers, and then uint64 stores unsigned integers using 64 bits. Not only does MATLAB allow us to store unsigned integers, but we can also store signed integers, meaning not only non-negative, but also negative numbers. Those signed integers come in 4 flavors: int8, int16, int32, and int64, indicating the number of bits used to store that information. When the u is gone, it is no longer unsigned. In other words, int8 is signed integers stored using 8 bits. Similarly, int64 is signed integers stored using 64 bits. Notice that each unsigned has a signed cousin, meaning that we have a total of 8 data classes to store integers in MATLAB, some of which are just non-negative, some of which can be negative. The other 2 numeric data classes that we have are single and double. Double precision arithmetic is what we do by default in MATLAB. So unless I specifically typecast a variable using some other numeric data type, we will always store that as a double. We saw that if we set x equal to 6, and then we go ahead and test, let's go ahead and see whether or not it's true false. Is the letter x stored as a double? Notice that the result of that test is a 1. In other words, x is stored as a double because by default, MATLAB will always store that as a double. On the other hand, if I wanted to use the single class, let's go ahead and write y is single value of x. If I then test, is the letter y stored as a double, that result is going to get 0 because I am typecasting this using the single floating point numeric data class. Similarly, we could say that z, let's go ahead and store z as a signed integer using 16 bits, and we'll let it be equal to 6. Notice we can run a test. Let's go ahead and test, is the variable z stored as a double precision floating point number? MATLAB says, no, it is not. Let me ask us instead, is it stored as an int8? Nope, it's not. It's producing 0. What about int16? Ding, 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 ding. MATLAB is saying, hey, the variable z is stored using the data class int16. In other words, the isA function allows me to test the data class that is used to store the values of a particular variable. Let's take a look at an example with a string. So we'll call this eg_string. Remember we said that strings are stored with double quotation marks. Particularly, this is a string because it has double quotes. Let's go ahead and store that as a 1-by-1 string array. And then we're going to go ahead and test. Let's test whether or not this is true or false. Is the example string stored using the character data class? In this case, MATLAB produces a false because the variable eg_string is not stored using characters, it's stored using strings. If I were to change my test instead to ask, is this a string? MATLAB produces 1, which is true. There are some remaining data classes that we haven't talked about, one of which is called a table. Table arrays store data in tabular form. This is really, really nice for presenting information or storing data using different structures. We also have something called a cell data type. Cell arrays allow us to group data of different types together and kind of organize them accordingly. And then there's also called data structures, or struct. Struct. Data structures allow us to group arrays using something called fields. This is also something called dot notation. One of the goals that I have in my introductory classes is that we actually work on projects that involve all of these data types so you get a sense of what MATLAB is doing behind the scenes with all the different fundamental data types that it offers. For our purposes in the very introductory modules in this class, we're going to really focus in on logical data as well as all the numeric classes so that we can really understand what's happening there. With that in mind, there's actually something called categories for numeric data. So out of the 16 array-based data types, 10 of those are what we call numeric data. So if we go back to MATLAB and then look in the workspace, remember we had 3 variables whose actual output value was 6, but the corresponding data classes that we used were different. So Z was stored using int16, Y was stored as a single, and X was stored as a double. So let's go back in here and we can test whether or not Z stores numeric data by the following line of code. So true, false, is the variable Z used to store numeric data? And in this case, MATLAB is producing the value of 1 because indeed Z represents numeric data. It is stored as one of these 10 classes. Similarly, if I ask the question, is the value of Y stored using numeric data? Yep. One of the 10 numeric data classes is used to store the variable Y, so MATLAB is producing a logical 1. We actually have a further refinement of testing logical data, which is not only numeric, but actually 2 categories underneath that, either integer data or floating point data. So there are 8 integer data classes. Those are uint 8 through 64 and then int 8 through 64. And then the floating point, we have 2 different versions, which is single and double precision. Let's go ahead and test whether or not the variable Z is stored as a float. So we'll create a test, true, false. Is the variable Z stored using floating point data? MATLAB is telling us no. Is the variable Z stored as an integer? Let's test that one. MATLAB tells us true. In other words, we know that Z is stored in one of the 8 integer classes. Which class is it stored in? Well, it's stored in integer 16. That's exactly what my test produces. Similarly, we could do another test. Is the variable, let's call it X, stored as floating point data? Yes, it is. Okay, what type of floating point data is it? Is it a single? No, it's not. Is it a double? Yes, it is. All of a sudden, we're able to test the class of the data based on the isA function. In other words, the isA function allows us to test what type of data class is used to store information in MATLAB variables. This relates to our third purpose of logical data, which is to test the state of MATLAB variables. In this video, we're focused on testing the state of numeric data, though we've seen some examples where we can test the state of non-numeric data. Over here, we have categories of numeric data. There are 10 different data classes that are categorized as numeric. Subcategories are either integer and floating point, and then the data types break out as seen in this table. That leads very nicely into the community challenge for today's video. In the comment section below, I want you to respond to the following question. Why would you want to be able to test the data type used to store variables? What applications would arise in which it might be useful to be able to run tests on the type of data used to encode MATLAB variables? You can write your own answers to those questions, or you can link to other people that have described that well in the comment section below. Of course, I always welcome your feedback, questions, and concerns. Thank you so much for your attention. I'll see you in the next video.